Hi, this is Recompile, and in this video we're going to go over some more intermediate functions of ecuflash and how to utilize them to tune your Evo. Specifically, we'll look at rescaling the axes, the X and Y axes, and also how to interpolate values to maybe to speed up the tuning process, and also kind of as a sanity check on your tune to make sure that you're not doing anything too outrageous as you go along. So at this point you should already be familiar with how to work with the basics, fuel and timing maps, how to relate data logs from a program such as EvoScan with ecuflash, and how to make some minor edits in the maps within your ECU. So let's go ahead and open up a stock ROM image here. And let's start by looking at a timing map. So, looking at the stock timing map, there's a few things you'll notice. We kind of brushed on this topic briefly once before, but basically it's a smooth progression of ignition timing. As we go up the load column, across the load columns and down the RPM rows, we kind of have a progression of ignition timing here. It's fairly smooth. There's not a lot of jumpiness. We don't have any blocks where you have a 12 in one cell and a -1 in the cell directly next to it. It's a much more smooth transition, and that's intentional because the engine typically responds best to smoother transitions of timing and fuel maps, and you don't want to shock the engine into doing anything ridiculous. You kind of want this type of smooth ramp. So the first idea that we'll introduce here is the ecuflash interpolate functions. And the interpolate functions are listed in the edit menu here. We haven't touched them yet, but they're below all the increment, decrement, set data, add data, multiply data, and then down here we have interpolate. Interpolate vertically, horizontally, or in both dimensions. So all interpolate really does for us is it allows you to very quickly set up a progression of values in any map of any type, whether it's timing, fuel, or otherwise, that kind of follow a linear trend. So what I mean by that is if we take a look at this trend right here, for example, we have timing values as we go from 180 load to 260 load along 3500 RPM. And the timing values are progressing downwards, 9 to 6 to 4 to 1 to -2. So it's a fairly linear function here, not specifically, but for argument's sake we can say it's pretty linear. If we didn't have values in here, or if we had tried to alter our tune and these values were nothing really meaningful, but all we knew was that the 9 seemed to work fine here and the 2 seemed to make sense, so the -2 seemed to make sense here. An easy way for us to populate the values in between those two is to use the interpolate horizontally function, which is also the H key. So when we do interpolate horizontally, we actually get the same type of values that are in the stock ROM. We get 9, 6, 4, 1, and then the -2. And the reason is because it's calculating what the progression should be based on this starting value and this ending value, and then populating those cells with what makes sense in terms of linear functions. The same applies to the vertical interpolation function. So if we took the interpolation, or if we took the progression of timing in this manner, where we go from 2 to 3 to 6 to 7 to 9 degrees, and we took some of this away, and then we just highlighted from the 2 to the 9, and we interpolated that vertically, we get a roughly the same progression of timing. It's not identical, but it is close. So it's basically attempting to mimic what you'd expect to see as you extend down a load column or across an RPM row, it's attempting to simulate what the typical type of progression of values would be, and to not make any severe changes along the way. Now, of course, if we just undo that, if we had, for example, 20 in here, that's obviously going to throw off our interpolation, because the 20 doesn't really make sense. So, but when we interpolate between 2 degrees and 20 degrees vertically, we get a much higher progression. It's got to make up the difference in terms of a linear equation going from 2 to 20 and the points that hit in between. So you got to be careful when you usually interpolate not to make such drastic changes, because going from a 2-degree cell to a 6-degree neighboring cell isn't always the right idea. You want to have cells that neighbor each other, particularly when we're looking at timing. We kind of want to have cells that neighbor each other with maybe only 1, 2, or 3 degrees of timing at most, varying between the two neighboring cells. We really don't want to have any drastic changes like that. So the other interpolate function here, interpolate 2D or in both dimensions, basically accomplishes the same task as vertically and horizontally, but it's with one function. So what we can do is we can actually select an entire block in this map, and then if we just deselect these corners here to give us our endpoints, we'll set everything in between equal to 0. So all we know is we want timing to progress from 6 to 15, going downwards on the left side of this block. We want it to progress from -2 to 6, going downwards on the right side of this block. And we want it to progress from 6 to -2, going across on the top side of this block, and from 15 to 6, going across on the bottom side of this block. So based on those 4 pieces of information, ecuflash will fill in everything in between with the linear equivalent of interpolated ignition timing values. So what it's done here is it's made as smooth of a transition as possible from 6 degrees to -2 degrees, from 6 degrees to 15 degrees, and so on, in every means possible, filling in all values within that region. So you probably don't want to be doing what we just showed for an example, basically, defining only 4 cells in a very large area and then relying on ecuflash's interpolate function to fill in very large areas of your tune. You really don't want to do that. Really, we just did that for demonstrative purposes. What you want to use it for, in many cases, is for cleaning up the tune, or for setting up areas of the tune that maybe exceed the bounds of what you're data logging, and basically using it as a safety measure. And what I mean by that is, let's say, for example, in your data logs, you're progressing across the timing map in a stock-like fashion, and you're really not exceeding 220 load, we'll call it. So really, this is basically the upper bound that you're hitting, we'll say, in your data logs. If that's the case, all the stuff beyond 220 really is essentially for safety's sake, and not necessarily meant for you to use on a daily basis as you're driving the car around, or if you're racing the car. The rest of these cells are more there as an emergency fallback. So if that's the case, and let's say you've gone through and you've made a bunch of changes to your map over here, and let's say the car happens to I'll just make some very arbitrary changes in the timing map, and we end up with this type of timing map after you've done all your tuning. To figure out what is appropriate in these cells here that you're never actually hitting in your logs, we can basically zero them out, and we can take what we've tuned up to the 220 load column, and we can bring that down to the 300 load column and paste those values in there. And what we'll do is we'll say these guys here should be 6 degrees less aggressive than what we had in our 220 load column. And 6 really is just kind of a number I picked out of thin air, but basically all we're saying is if we're exceeding our intended load by 80, which is a considerable amount, if we're going from 220 to 300, that for safety's sake we should pull at least 6 degrees of timing in order to make up for the fact that something's wrong and we're overboosting. So rather than have you try to calculate yourself what belongs in between these two columns, we can just select everything in there and we'll do a horizontal interpolation. So now we have a nice smoothed timing map that looks appropriate. It doesn't look jagged. We're going from 6, 7, 8 degrees in the 220 down to 5, 6, 7, down to 3, 4, 5, and so on until we end up with our ultimate safety values in the 300 load column. So it can be useful in that respect in tuning the safety bounded areas of your maps. Just for simplicity's sake, really. You can go through and manually make all these changes, but if you only want to do it in a short period of time, you can leverage those functions of ecuflash and save some time. So the saving could be done for your vertical interpolation going down, or perhaps going back up. If you're not really hitting these high load cells, say anything over 100 load, but under 2000 RPM, if you never really encounter these cells in your log, but you still want to have some meaningful values in there because you know that you've tuned everything else below this region, this is your fully tuned area, and everything else above here is basically going to be safety, you can do the same type of thing. So you can take your top bounded tuned area and put that up at the 0 RPM row. We'll do the same type of thing. We'll say this is going to be 6 degrees less aggressive for safety's sake. And given that difference, we'll interpolate vertically. And there we have it's filled in those regions with something that's acceptable, a progression that ranges from the values we had down here at 2000 RPM to the values we put up here at 0 RPM. And it does so in a nice smooth manner. So that's the interpolate functions of ecuflash. I honestly don't use these too often myself. I very rarely do. But if you have to start from scratch, if you have to check on your work, or you want to see what makes sense for timing values given a starting position and an end position, you can use these even if you're just testing out what ecuflash would put in those cells in this instance. It's not a bad thing to utilize. Let me just close this out so we don't have those cell change boundaries to look at. Okay, so we've covered the timing map. We can do the same type of information, the same type of functions in the fuel maps. I won't go over it again because you basically get the idea. But another important thing that you can do in regards to working with the structure of these maps is rescaling. And you may be familiar with rescaling. Some tuners offer it as included in their professional tuning services. Others don't really bother. But in reality, in my opinion, it's a very worthwhile task. It makes sense to rescale your load and RPM axes to match your particular car, especially if you're not really stock and you've done quite a few mods. It just doesn't make sense to leave these tables set up the exact same way that you have. So we'll cover that in another video.